Hello, grade 7. This is Mrs. Lopez. Today we are working on Module 1, Lesson 2, Proportional Relationships. One thing you need to know about proportional relationships between two quantities is that two quantities are going to be proportional if their ratios are equivalent. That's all the main idea of this lesson. So let's go ahead and do example 1. Pay by the ounce frozen yogurt. A frozen yogurt store sells its yogurt at a price based on the total weight of the yogurt with toppings in each cup. Each member of Reagan's family weighed their cup, and this is what they found. Determine if the cost is proportional to the weight. So here we have 4 members of the family, 1, 2, 3, 4, who got their cups of yogurt, and this is the weight of the yogurt, and that's how much they paid. Now let's see if if the cost is proportional to the weight. Since we are looking for the cost to the weight, we are going to look for the unit rate, which is dollars per ounce. That's what we are looking for, dollars per ounce. So since we are looking for dollars per ounce, we are going to divide dollars by the number of ounces. So we are dividing 5 by 12 and a half. We are dividing 4 by 10. We are dividing 2 by 5. And we are dividing $3.20 by 8. For the sake of time, I'm going to do it myself and I will give you the answers. So 5 divided by 12 and a half is going to be 4 tenths. When I divide 4 by 10, I will also get 4 tenths. When I divide 2 by 5, I will also get 4 tenths. And when I divide $3.20 by 8, I will also get 4 tenths. So see how all of the answers are exactly the same. Since the answer is exactly the same, it means all of these ratios are proportional, and that means that the cost is proportional to the weight. The cost is proportional to the weight. Okay, let's move on to the next. So here we have a cooking cheat sheet. Those of you who take cooking classes or like cooking at home, you know that all of the measures that you are taking have to be proportional for the food to taste the same. So um, if you are making pizza and you put too much sauce in your pizza, um, for it to taste the same the next day, when you're cooking the next day, you will also have to put exactly the same amount of sauce, right? Even if you are making a different amount of pizzas. So in the back of a recipe book, a diagram provides easy conversations to use while cooking. Here we have conversions, different conversions to use while cooking. So here we have cups and ounces. These are the number of cups. Here is the number of ounces. The one that you probably know is that there are 8 ounces in 1 cup. And we need to see whether or not all of these are exactly the same. So here I see that 1 cup is 8 ounces, 2 cups is 16 ounces. So I know that these are exactly the same because 2 cups, 16 ounces is when I multiply by 2 or divide by 2, right? Vice versa. Let's see if 4 and 1/2 is going to be exactly the same. So if I divide 4 by 1/2, 4 divide by 1/2. If you remember how to divide fractions, you should know that when I divide by a fraction, I need to multiply by its reciprocal. So 4, I'm multiplying by the reciprocal of 1/2, which is 2 over 1. Uh, Reciprocal is a flipped fraction, and I will get 8. So when I divide 4 by 1/2, I will also get 8 for 1, right? So that is exactly the same. Again, So that means that I have three ratios that are the same. When I divide 12 by 1 and 1/2, I need to make sure I'm dividing by a fraction, not by a mixed number. So I'm going to change my mixed number into improper fraction, which is 12 divided by 3/2. And now I'm going to multiply by the reciprocal, 12 multiplied by 2/3, and that will give me 8 as well. Okay, so that is again the same thing. If I were to just write that down here, so you can all see 8 divided by 1 is 8, and 16 divided by 2 is 8 as well. All of these numbers are the same. 0 divided by 0 is also an important thing to know, because if there is 0 ounces, you can make 0 cups, right? Um, I don't have to have an 8 as an answer there. I just know that it makes sense. Um, 0 ounces gives you 0 cups. So the ounces are proportional to the cups. The ounces are proportional to the cups. Okay, moving on. And here we have the next exercise. During Shelton's physical education class today, students visited activity stations. Next to each station was a chart depicting how many calories on average would be burned by completing the activity. Here we have again a double number line. We have time in minutes and we have calories. Um, and we need to find out whether um, calories are proportional to time. Since we are looking for calories to time, we need to find calories per minute, right? So we are going to divide calories by the minutes. So 11 divided by 1, 11 calories divided by 1 minute will give you 11 calories per minute. 22 divided by 2 will also give you 11 calories per minute. 33 divided by 3 will also give you 11 calories per minute. And 44 divided by 4 will also give you 11 calories per minute. If I look at 0, 0, 0 divided by 0 is 0. But let's see if it makes sense. If you don't exercise, you don't burn calories, right? So that also makes sense. Um, so the answer, the number of calories is proportional to the time. The number of calories is proportional to time. And how do I know? Is because I did the work here. It's already shown, so I don't need to explain. Um, or I can say I know because there is 11 calories in each minute for each minute of exercise. Because we burn 11 calories each minute. Okay. If Shelton jumped rope for 6 minutes, how many calories would he expect to burn? So notice how here in the number lines we have 1, 2, 3, 4. We can add 5 and 6 minutes, and we can continue on this number line as well. I also see the relationship. So if I multiply the number of minutes by the number of calories per minute, I will get the calories burned. So if I do 1 times 11 is 11, 2 times 11 is 22, 3 times 11 is 33, 4 times 11 is 44, 6 times 11 will give me 66. So 66 calories. will be burned by exercising 6 minutes. If Shelton jumped rope for 7.5 minutes, how many calories would he expect to burn? Exactly the same way, we are going to multiply 7.5 minutes by 11. Notice I'm also writing 11 in parentheses. I don't have to show a multiplication sign to do the multiplication. So if I write it this way, you should know also that I'm doing multiplication. So 7.5 times 11, 7.5 times 11 will give you 82 and 1/2 calories. And again, I know it because every minute I exercise, I burn 11 calories. So if I exercise 7.5 minutes, I need to multiply that by 11 to find how many calories I will burn. Okay. All right. We have another exercise here, summer job. Allison spent the summer helping out at her family's business. She was hoping to make enough money to buy a new 220 gaming system by the end of summer. Halfway through the summer, after working 4 weeks, she had earned $112. Allison wonders, if I continue to work and earn money at this rate, will I have enough money to buy the gaming system by the end of summer? To determine if she will earn enough money, she decided to make a table. She entered her total money earned at the end of week 1 and her total money earned at the end of week 4. Will she save enough money? Okay, so one important thing that you can see from this table is if her rate is going to be the same, right? So when she said, if I continue to work and earn money at this rate, so the rate is going to be exactly the same. So for each week, she's making $28, right? That is your unit rate right here, $28 per week. That is unit rate, okay? Um, so if I know that each week she's making $28, all I need to do is to multiply every week by $28 to be able to fill in the um, chart and to see whether she will make enough money. Another thing I can do is to use proportional relationship or to use equivalent ratios. So if I have here 1 to 28, 4 to 112, because if I multiply 1 by 4, let me put it here, 1 times 4 will be 4. So 28 times 4 is 112, and that works. So if I want to get to 8, I can find the equivalent ratio as well. If I multiply 4 by 2, I will get an 8. So if I multiply 112 by 2, I should be able to find that amount of money. So 112 times 2 is going to be $224. Will she make enough money for the gaming system? Yes, she is going to have enough money, and actually she will make $4 extra. So I just answered the question. She will have save enough money. She will save enough money. We can just finish here because we are kind of filling in the table here. If I want to fill the table, if I was asked to fill the table completely, and actually I do need to do that, all I need to do is to multiply each week by the number of dollars. So if I multiply 2 by 28, I will get 56, right? If I multiply 3 by 28, I will get 84. If I multiply 5 by 28, I will get 140. If I multiply 6 by 28, I will get 168. And if I multiply 7 by 28, I will get 196. If I multiply 0 by 28, I will get 0. So all of this relationship is multiplicative relationship. In each case, I'm multiplying the number of weeks by 28, right? 1 times 28, 2 times 28, and that continues on for the entire table. Times 28, times 28, times 28, times 28. You cannot use addition in proportional relationship, just saying. Only multiplication or division. Last question here. Are Allison's total earnings proportional to the number of weeks she worked? How do you know? Yes, it is proportional because every week she is making $28. All the numbers are going to be exactly the same in terms of their of the value per week. Okay, so the earnings are proportional to the number of weeks because every week she is making $28. That will be enough for you to answer this question completely. All right, that's it for today. We do have another lesson coming up, so please do your homework, and if you have questions, we will address them at the next lesson.